Hi, this is Wendy Lightheart, and today we're going to learn how to solve some quadratic equations using the square root property, and then we'll take a look at some examples where we can apply what's called the Pythagorean Theorem. The square root property says that if u is an algebraic expression and d is a non-zero real number, then u squared equals d, that equation has exactly two solutions. One of those solutions is u equals square root of d, and the other solution is u equals negative square root of d. Equivalently, if u squared equals d, so if we have some perfect square involving a variable on one side and a number on the other side we'll call d, then the solutions to that is u is equal to plus or minus the square root of d. You can think of it this way. We can take the square root of both sides of an equation to undo the exponent of 2. And when we do this, we get two solutions. So in order to make sure we get both solutions, don't forget that plus or minus sign. So let's look at some examples. This first example, we want to solve 5x squared minus 15 equals 0 using the square root property. So here's our given equation. And to solve equations with the square root property, your first step is to isolate the perfect square involving x. So here we want to isolate x squared. So we can do this by adding 15 to both sides and dividing both sides by 5, and that will give us x squared equals 3. So now that the x squared is isolated, we can apply the square root property. So we can think of this as square rooting both sides, and we're square rooting the left side so we can undo that exponent of 2. So we end up with our two solutions of positive square root of 3 and negative square root of 3, and that gives us our solution set. Here's another example. This time we want to solve 4x squared equals 49. So here's our given equation. So the first step is to isolate the x squared. To do that in this example, we can divide both sides by 4. And that will give us x squared equals 49 divided by 4. Now that we've isolated the x squared, we're ready to apply the square root property, where we take the square root of both sides, and we make sure we don't forget that plus or minus sign. And then we simplify. So the left side will simplify to x because we're just square rooting that side so we can undo the exponent of 2 that was on the x. And then on the right side we can apply the quotient rule that we just learned and take the square root of the top and the square root of the bottom separately. And the square root of 49 is 7 and the square root of 4 is 2. So our solution set includes 7 halves and negative 7 halves. Now here's another example that's a little bit more complicated, but we still can use the square root property to solve this because we have a perfect square involving x that we can isolate, and we'll only have a number on the other side. So here's our given equation. So we first want to isolate the x, or the perfect square involving x. So in this example it would be the binomial x plus 2 squared. So we can isolate that perfect square by dividing both sides by 3, and 36 divided by 3 is 12. So now we have the perfect square involving x isolated, and we have just a plain number on the other side. This is a scenario where we can apply the square root property. So we take the square root of both sides to undo that exponent of 2. So the left side will just be left with x plus 2. And the right side, we want to make sure we have that plus or minus sign there. And then we have the square root of 12. Now, because we end up with x plus 2 on the left and not the x by itself yet, we're going to have to isolate the x with some more steps. So what we're going to do is split this up into the two solutions into two separate equations. So one will be the x plus 2 on the left and the positive square root of 12 on the right. And the other one will have the x plus 2 on the left and the negative square root of 12 on the right. And this just makes it easier to solve for x. And we can do that by subtracting 2 from both sides of the equation. Now when we do this, we want to put that negative 2 immediately to the right of the equal sign and move that radical over. And we do this because we want to get it into a form that we'll be familiar with once you learn another method for solving quadratic equations in the next class called the quadratic formula. So that will give us negative 2 plus square root of 12 for the one on the left, and the equation on the right will give us x equals negative 2 minus square root of 12. So now, notice that the square root of 12 can be simplified. So we have to simplify that before we can give our solution set. So let's simplify by rewriting the radical square root of 12 as square root of 4 times square root of 3, since square root of 4 is the biggest perfect square factor of 12. And then the square root of 4 is 2, so both of those square root of 4's will get replaced with 2. So that gives us our two solutions. One of them is negative 2 plus 2 square roots of 3. And notice that those terms cannot be combined because they're not like radicals. Negative 2 is a constant without a radical on it. And then the 2 square root of 3 is a radical term, and so we can't combine those any further. And then our other solution is x equals negative 2 minus 2 square roots of 3. So we put those inside the curly brackets separated by a comma. So again, our solutions are negative 2 plus 2 square roots of 3 and negative 2 minus 2 square roots of 3. Now we're going to see how we can use the square root property to solve problems that involve the Pythagorean theorem. So if you're not familiar with the Pythagorean theorem, this is a theorem that applies to all right triangles. And a right triangle always has a 90-degree angle, and you can see the marking by a little square that's given in that corner to tell you that that's a right angle. So this says that if A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. Note that the legs are the two sides that form that right angle. You can also think of them as the only two sides that actually touch that right angle mark. So we could call one of those legs A and the length of the other leg B. That makes our third side the hypotenuse, which we label as C. Note that the hypotenuse is easy to identify by noticing that it will always be directly across from the right angle. So let's see how we can apply this theorem. So here's a right triangle, you can tell by the marking, and we want to find the missing length. So we start by labeling our three sides. So note that the side directly opposite of that right angle is the missing length, so we're going to label that as C because that's going to be our hypotenuse. Then the other two sides which form that right angle are the legs, so we'll call one of them A and one of them B. And it doesn't matter which one you label as A and which one you label as B, as long as you have identified the two legs correctly and let one of them be A and the other one be B. So now we can use that equation from the Pythagorean theorem by replacing the A, B, and C with the appropriate numbers or variables. So the A will be replaced with 5, and the B will be replaced with 12, and the C is going to stay as a C since that's the side we need to find. Now we simplify, since 5 squared is 25 and 12 squared is 144. Now we can add those two numbers together to get 169. So notice we have something of the form of a perfect square involving a variable on one side and a plain old number on the other side. So now we can take the square root of both sides, and we have our plus or minus symbol there. But of course, we're looking for the length of a side, so we really can ignore the negative solution in this case. So the side length C is equal to 13 centimeters. Let's look at one more example. Here we want to find the missing length of this right triangle. So the side directly opposite of the right angle is the hypotenuse, so that's going to be our C. So C is equal to 4 inches. Then the other two sides which form the right angle will be our A, which is the missing side length, and B, which is 3 inches long. Now we're ready to use that equation, A squared plus B squared equals C squared, by replacing the B with 3 and the C with 4, and the A, of course, we can leave as a variable. And if you want, you can replace the A with X, but you don't necessarily have to. It just needs to be some variable. Then we simplify, so 3 squared is 9 and 4 squared is 16. Now for this one, the perfect square is not isolated like it was last time, so we're going to have to subtract 9 from both sides to isolate that A squared. So we get A squared equals 7, and now we're ready to apply that square root property by taking the square root of both sides, and technically we would have that plus or minus symbol there, but for this problem we can ignore the negative solution since it doesn't make sense to have a negative length. And the square root of 7, that's not a perfect square, so you'll need your calculator, and if you take the square root of 7 in your calculator and round it to 2 decimal places, that will be approximately 2.65 inches. So now you've learned another method for solving quadratic equations, and those will be the kind that have a perfect square involving x that you can isolate, and the only other term you would have would be a constant, a real number, on the other side. Well, that's it for today. See you later.